Everyone. This is Amar Davrekar from Design Tech Marketing. So I welcome all of you for today's webinar on Altair Physics AI, how Physics AI takes simulation to the next level. So today's presentation will be delivered by Mr. Guda Karthik. So Mr. Guda Karthik is a senior technical engineer with Design Tech. So Guda Karthik, he is working with Design Tech and having experience of more than 15 years. So just to introduce about the tool, this is a GoToWebinar tool, and we'll be having a two-way communication over here. First, we'll be showing all the presentation slides, and maybe at the end of the session, we will answer all of your questions. So I would request everyone, if you have any questions in the middle of the session, you can definitely type them in the chat window, and we will take up all the questions at the end of the session. So shall we start with the presentation now? So Guda,
Yes.
shall we start with the presentation?
Yes,
Okay,
we can
okay,
start. I hope
okay.
screen and audio is clear.
Yes, the screen is visible and your audio is also very much clear.
Great. So thank you so much, Amar, for the
Yes.
good introduction about me. So very good afternoon, one and all. Myself, Guda Karthik, technical support engineer for Altair Hyperworks. So present, I'm working as a senior technical manager at Design Tech Systems Private Limited. So my experience is around 17 years plus. So where I have supported many esteemed clients across India, diverse sectors, I can say, including defense, space, aerospace, consumer goods, and automobile. And my expertise spans technical management, and I have played a key role in delivering innovative solutions to meet all my client needs. So I'm proud to be a part of the Design Tech family, and looking forward to continue to support you all as well. Whoever is attending this today's presentation, and feel free to ask the questions after the particular session. So right now I'm going to take you overview of entire Altair portfolio of Altair AI ML and digital twin solutions. How advanced technologies are there in Altair, we are going to understand. Yes. So today I'll walk you through how Altair leverages AI ML and digital twin technologies to accelerate all the engineering innovations, which reduces your cost and improve the efficiency across different industries. So today's introduction about AI and ML, deep learning, and like Altair tools we are going to discuss. So our vision as Altair, so we want to computational intelligence, which will drive the customers and scientists to innovate their products more connected, safe, and sustainable future. And we have around 16,000 plus customers worldwide, where the Altair has been recognized as a technology leader in each and every domain which is showing on the screen. And the key takeaways from the Altair, whatever the customer listed here, so they have trusted worldwide across all the industries, and they're utilizing for the mechanical, aerospace, space, I can say, UAVs related products, data analytics, machine learning, physics, AI. So AI, ML, I can say telemetry related things. Okay, so we have many customers who are into Altair family and utilizing our tools for the extensively. And these are all our main customer database. Just we want to showcase on the screen. And yes, we are talking about the system integration and a partner ecosystem with Altair, Design Tech, and other partners like this. So L&T, Tech Mahindra, and Wipro. So our network of partnerships with these system integrators, like for AI/ML, and like you can say about globally multinational companies, and where we help you to stay ahead for the entire workflow of your product lifecycle. So we will support and guide and take the inputs from the customer, and we will help the users of the national and multinational companies like this. So let's talk about the mega trends, and which are like you can talk about the current trends like EVs, electric vehicles, AI driven simulations technologies, and data driven, which is a decision driven by data, and semiconductor industries and cloud and AIML and decarbonization. So these are all the Altair trends and the industry trends in nowadays in our industries. So where Altair, how it is for all these mega trends, how Altair is going to address. So that is where Altair will suitable. Where here, if you see about why Altair, so we have a best in class data analytics and AI and streamlined data visualization tools where you can optimize and simulation. You can do, you will get the expertise of the validation of your products with the help of Altair. And it's a global domain and simulation expertise. So we have our own scientists and engineers sitting in India, like Bangalore and Pune based. We have our own development team who is sitting and exploring and getting the inputs from the customer. They develop the product to meet your requirements. And that is where Altair is so keen about the customer input and the deliverables of the supporting platform. And here the automation technology, Altair is an automation technology leader worldwide and the leader in HPC technology. And we have open architecture, so we can talk to any CAD and CA tools. And we have our own unique licensing system. It's a patented licensing unit system, I can say. So that's about the Altair. So if we talk about the like Altair, so it's a platform especially for the engineers, designers, and scientists who can work on design and simulation platform, who can also work on HPC and cloud platform, data analytics, and AI platform. So for any innovation or foster innovation, Altair is a tool which speed up the product development cycle with a Altair Hyperworks. And you can also use cost effectively, scalability wise. We have computing power. And if you are into cloud also you're interested, yes. So work from anywhere, perfect for hybrid and global teams. And if you are interested in security and governance, we have enterprise grade compliance and user management. And any real world applications like automotive, you can simulate the crash test, optimize aerodynamics, aerospace related like design lighter in weight structures, stronger components. If you talk about energy, you can run the digital twin simulations, especially for wind turbines or grids. And if you're interested about life sciences, where you can do a modeling of biomedical devices or run AI driven discovery using Altair tool. So that is where, so Altair will help you to compute and collaborate nicely with the Altair 1. So that is where we'll call it as Altair 1. So collaboration of three different verticals. And yes, so this is where a comprehensive cloud innovation gateway for engineers. So when we talk about Altair Physics AI and yeah, and Rapid Miner, so which are the AI tools in Altair. So this is a particular video which explains about the Altair high performance computing and data analytics convergence. So the power of AI using Altair, you can understand with this particular video. So starting from scratch, if you have a design variants like 1, 2, 3, 4, or if so old data, like any old data you have it, old result files, so that can be predicted and keep it ready. Like that is nothing but you can train your model using physics AI, which is a part of Altair, where you can get the AIML, you train the model and keep it ready. So whenever the new design comes in front of you, you can do the simulation. Without any traditional methodology, you can predict the physics. So this is an example of hood head impact analysis. And yes, so multiple designs, definitely you, as a product lifecycle developer, you will get a more designs and more design validation you generally does. So what physics AI helps you is whenever new design comes, no need of creating a mesh, no need of creating a material creation, no need of doing any physics simulations. Whatever the old data you have it, result files that you are trained and kept it ready for the future physics validation. So that is where physics AI will help you. So 1,000 times faster results you are going to get. So whenever you talk about CFD, whenever you talk about the explicit, so it is a long duration time it will take. So maybe hours, maybe days, maybe months. So to avoid these kind of time, okay, which is valuable for the any industry. So to avoid that kind of uh, time saving, so we have a physics AI in Altair where you can generate a physics prediction in 1,000 times faster than the traditional methodology. There is other product called Rapid Miner, which is going to uh, do a reduced order technique, whatever the real time scenario, or it may be a test scenario, okay, simulation scenario. So that can be reduced, whatever the simulation uh, steps you are doing it, so that has been reduced and you can predict the physics in ultra fast way. So physics AI and Rapid Miner, so both are the tools which are part of Altair. So that is the example which is shown in the video. And what is Altair Physics AI? So whenever customer asks the questions about a different type of, like it, so with general questions like this, so on the slide you can see. So if it is taking too long to get the answer from CAE, is there any way my designer can evaluate design fast? Yes. So Physics AI is a tool where it can answer your like any physics prediction you can do in a very less time, in a minute, to predict no matter how long the simulation takes. So what it does is, it is a 5-step process that I'm going to show in the next video. Okay, it's a 5-step process. Just you have to create a directory. You call your result files. So as you know, AI/ML needs a data. It may be a simulation data. It may be a real-time test data. If you provide that in a better way, okay, it will predict in a very accurate way. So that is where AI/ML will help you to predict the physics simulation. So first of all, the first step is creating a directory. Call the all the result files. It may be a any product, I can say ANSYS, Abacus, LS-DYNA. If you talk about Nastron, if you talk about OptiStruct, Radios, okay, our own tools, any result file, the physics AI can talk. And that result files you are bringing into the physics AI, and then you can train the model and keep it ready for the new design when it comes. Okay, so no need of doing a traditional methodology. It reduces all the traditional techniques. Okay, directly you bring a CAD model and you can predict it. So that is where the first question will be answered. So any design engineer can use this physics AI on the direct design part itself. No need of FEA methodology. Traditional methodology is not required. So directly it will predict, depends on your trained model. So we cannot afford to run DOE studies. Is there any way to train ML with existing data? So physics AI uses existing data itself. If you have a, if you talk about any defense lab or any commercial labs, okay, so we have a existing data. It may be a PDF, it may be Excel sheet, it may be a result files. I'm talking about everything. Okay, so presently physics AI will be suitable for the 3D representation, means 3D models. When I'm talking about ROM AI, it talks about the data prediction. So if you have a data in a PDF or Excel sheet, so that you can call it. So physics AI needs a result files, whatever I just spoke about, different type of simulation results, you can call it, and you can do the physics prediction. The third question is from user is meshing is tedious and lengthy. So is there any way to evaluate designs without meshing? So we have a tool called Physics AI where you can predict on the direct CAD model. So that can be helpful for the customer. And so benefits of AI/ML. So whenever the user think about AI/ML, so they'll think about the coding. So here in Physics AI, there is no coding. It's a user interface tool, no code, low code tool it is. So directly you can bring the result files, okay, and you train the model using AI/ML, and it uses a geometric deep learning. There are multiple techniques, like it uses a graphical neural network and transform TTS methodology it uses at the background, and it gives the result prediction to you. And that is where it is embedded in Altair product itself. So Physics AI uses uh, like AI/ML at the background, and it gives the prediction to you as a upfront. So Physics AI is a domain neutral. As I said, it can talk to any CA tool results. Similarly, it might be any physics, structural, manufacturing, NVH, electromagnetics, thermal, fluid, aerospace, any physics, you can predict it. It is not only for implicit problems or explicit problems. It is implicit, explicit, CFD, thermal, electromagnetics, all the physics it can be solved. So here one of the case study called case study from Magna. You can see the application of Physics AI for Crashbox. Here if you see this Crashbox general traditional methodology, it requires a 14 hours, and it is too long for the customers, so they were getting continuous new design variants. To avoid this number of hours, traditional methodology, using a hyper study, a synthetic data generation. They don't have any existing data for them. So using hyper study, we have given some design constraints and responses and objective to minimize the frequency or mass. So like that. So that inputs, if you give it in hyper study, it will generate a synthetic data. So that data you are going to give an input for the physics AI. So that when the user from Magna has given, so it predicted the results. If you see about physics AI, it takes 10 seconds to simulate, and you can see the contour and contour of FEA simulation and physics AI simulation. So, and if you see the comparison of results also, it is almost 135 MPa, sorry, 1.35 mm they achieved it. So if you see, instead of 14 hours, it has taken 10 seconds. That is why in 5-step process, easily the Magna users has uh, started utilizing physics AI to get the predictions very fastly for their number of design variants. Similarly, Hero is the company. So the challenges is handlebar on the motorcycle, which is very important part of its ergonomics. And you may take any Z bar, low Z bar or tracker bar or drag bar, different type of variants in a bikes. So they have a sports variant, they have a middle family variant. So that's kind of different variants. The designs of rods will be slightly changes. So that bar has been simulated. So generally it was taking 1 hour, and number of design changes were happening to do the all the ergonomic studies, and that is where physics AI predicted properly, and it has given in 10 seconds. So that is where the user has appreciated, and it has used the Hero company is using physics AI for that. And if you see these, another example of automotive hood, which is a head impact analysis. So if you see on the screen, so this is called historical data. First step, you are calling all the historical data. That means it may be a CAD, a different type of CAD models is showing in the training data, where it is already simulated and kept it ready at the background. And whenever the new design comes, okay, so that can be predicted with the help of physics AI. So first of all, historical data means what? You may CAD and CI, okay, once it is measured and simulated, okay, whatever the results are there, right, that results will be the historical data for us. So once the historical data is called, okay, the second step, you are going to train the model where geometric deep learning, it understands the shape, coordinate systems of each node, elemental data, okay, and the contour data from the results. Everything, it will be stored at the background for each and every result file. And what physics AI does is it combines all the S3D files or any result files, I can say. It combines all the contour. It understands the geometries in a very good way. So these are the changes that happened. These are the contours. So it combines all the result files together and keep it ready. So whenever the new design comes, okay, and you can also do the testing, how the physics AI is predicting before launching the new design. So you can also test with this trained model. Okay, you can also test and check the contour comparison as well as the accuracy wise. You can check it. So once the testing is done, then you can call the a new CAD design. Apart from these designs, there is a new design which comes in front of you or shared by the users. So just drag and drop into the user interface, and then you click on the prediction. So that's immediately it will predict by your trained model support. So there it will give you the metric score, that is nothing but a prediction score, how much percentage it is matched to your existing data. So more number of data, more accurate results you are going to get. So 85%, 95%. So it will show on the display to you. So that is where it's very simple in nature. It not need any coding here. So just directly you're dropping the result files into the data sets, you're training the model, and then you're testing the model to compare the physics AI, how it is predicting properly or not. Then finally you're dragging a CAD model into the physics AI window, and then you're predicting the physics. So here, if you see the physics behavior here, so it shows minus 42, that means 42% as prediction. So with this result changes, within design changes, and option 2, they have added a more accuracy, so more number of parts they have added. So 1 to 5 and here 1 to 6. Prediction for that is around 66%, you can see here. So that is where, so more number of results file if you give as an input, you'll get a more accurate results for you. So this is one of the video. So import head impact geometry. It has been simulated with the help of radios, and this is explicit code, and this is the AI predicted. You can see the prediction here at the right side, 90% it has been predicted. So this is there in a hypermesh window itself. So this is a 5-step process: project, dataset, training, model testing, and prediction. You can see this hyperview, and this is called a prediction here. 96% prediction. So immediately they have changed the location of the head also. Earlier it was here, so that prediction, and the second position of the impactor, true and predictions here. So that is where the advantage you have it with the help of physics AI. So easily you can predict it. Yeah. So just a minute, something is happened. Got it. So if you see, this is a physics AI step-by-step procedure. So you're creating a new project for that. And this is a particularly, it's a sheet metal forming case, means sheet metal forming simulation. It is. So traditional sheet metal forming simulations are very heavy. Okay. And that takes a huge time to run, especially with nonlinear materials, contacts, and large meshes. So that is where physics AI learns from all the existing data of your sheet metal forming simulations. Here in this example, we are reading all the data. We are calling that results files, set of these high fidelity simulations. You can see that H3D files, which is a Inspire sheet metal forming results. So that we are calling in the second step, like calling the data sets. And just click on the double click arrow over here so that it will come to the right side. And there are some options like enable train test split 80%, extract solid faces. So once you extracting the data sets are done, you can see this tick mark will come. Then you can close. And then you are going to train the model. So I'll fasten this particular thing. So you are going to train the model here. So this is called the trained model. It will understand the coordinates and part labels of your model and what all are the outputs you want to visualize it in the prediction so that you can call it. So it may be a displacement, stress, strain levels, reaction forces, anything. So you have to activate in the right side outputs. And by default, algorithm is written for 15 epochs, which is nothing but a 1500 iterations. So it will done the train now. It will train the model of all whatever the result files you have given. It will train that model. And yeah, you can see this log file whenever once it is created. So it will create a log file and loss curve. Both it will show to you. So it will start the log like 1 by 1500, 2 by 1500, like that iterations it does. Then you can also see the loss curve, which will show you the loss curve, whether it is prediction is happening in a proper way or not. You can check with the help of log and loss curve here. Okay. So here, if you see, this is how the log file, if you scroll down, almost 30 by 1500, it is happening. When you click on the loss curve as well. So finally it has done, and the loss curve should be constantly, it should come down. Okay. So once this is done, set active model. Now you can also add the test and train model to check the accuracy, how the physics AI has been done from the data, whatever we have provided. So it will check the results here. So you're testing your like true value as well as the physics AI prediction. Okay, so you can see this is a prediction value and bottom side is a true value. Okay, so almost you can say this 545, like 54 and 54, it is almost same. Okay, so here if you see, once we get the accuracy with the trained, then we can import the solver deck for prediction the results on the new design. So that is where we are importing it, the new design here. So new design does not have any material. If you see, there is no material, there is no boundary and loading conditions, no deck preparation at all. Directly you're predicting with the help of this option. So once it is predicted, you can see that again it will show the results for you on the new design. So that much faster it is. So what is the key benefits by using physics AI is, one is speed. So complex forming analysis reduced from number of hours to seconds. Accuracy wise, error margin was around less than 5% only compared to FEA results. And productivity, I can say. So this is again example of casting simulation of the same casting simulation results. And that casting simulation results we are predicting with the help of physics AI. So you're calling all the S3D files. Okay, the same methodology here. Okay, due to the time constraints, I'm forwarding this. So it is a 5-step process. You're training the model and you're testing that model, and you can see the true and prediction. It is almost same, around 4 to 5% of error percentage it is showing, because if you have more data, it will completely follow your true value. Okay, so with less S3D files, we are going to predict here. So in this example, with less result files we are predicting. So almost it is very close to the real-time prediction and with a new design AI. So now you can see import the new design, so which you can import a .fem file, which is only a mesh file. There is no boundary and loading conditions will be there in that. So this is only a mesh data. Okay, you can see that it is a FEM file. There is no loading conditions at all. Okay, you're just clicking on the prediction. This is how the prediction has given, and confidence level it is 1. 1 means almost 100% it has given proper results compared to the real-time physics simulations here. So that is an advantage to the user. Imagine now you can evaluate 100 forming design variants overnight instead of just 3 or 4. Okay, so that's the real power of physics AI over here. And coming to Altair, a rapid miner, which is a powerful end-to-end platform, I can say, especially for data analytics, machine learning, and AI. So designed especially for both technical and non-technical users to easily build and deploy the predictive models. And yes, the key features of this particular product is like you can also use drag and drop options to build data workflows, which has no coding actually. And it supports all the data preparation, model training, validation, I can say, deployment in one environment. It is a user interface with a single user interface, single environment. You can do a drag and drop interfaces, especially as I said, data preparation, model training, validation purpose or deployment purpose. And value proposition using this rapid miner is which will accelerate the data driven decision making across all over the industries, not only for the single industry, all vertical. This can be used, and most of our customers are whatever I have displayed in the third slide. All our customers are using this rapid miner as a tool for the like for understanding the AI, how it is helping them in the data analytics way. The current trends, which is AI is everywhere right now, and every person in every enterprise, we can see these are AI trends and data analytics. So AI is moving beyond data science, I can say, that which is like you can say like business users, developers, and analysts. So who can use this particular tool for their data analytics and data visualization using machine learning and data prediction. Okay, and yeah, using this rapid miner, which is a low code and no code platform, and which is a user friendly AI tool which is there in the market, and within the Altair tool itself, this particular module is available, and it is easy for non-technical as well as the technical persons. You can use leveragely the AI predictions over this with the help of rapid miner. I can say examples like chatbots, recommendation engines, and AI assistants available over the company wide, in your company wide. They can start utilizing this rapid miner as well. So using this rapid miner, you can also accelerate AI and analytics, which are crucial in your product lifecycle management. You can do the end-to-end digital transformations. This particular product also automate the workflows, depends on your understanding of the procedures and the methodologies what you follow in your company. That can also be customized here, and you can also automate your workflows with the help of rapid miner. So with this particular platform will help you uh, to generate very faster prediction using physics AI. Sorry, AI. And this particular tool can be installed anywhere like cloud platforms, any big data, and it is AI enabled and tool it is. So using data analytics and AI is a part of Altair now. So which is an end-to-end solutions which covers the full data lifecycle. As I said, data preparation, machine learning, deployment, and monitoring, all in one, in a place, in a single place you're going to get. And it is no code to pro code flexibility. It is an initiative especially for the beginners, no need of any coding here. So as I'm also new to this particular tool, so I can use drag and drop options, and if they have an experience, they can also easily learn this particular tool, and they can use the powerful of this particular tool, and they can expertise like Python, R, SQL integration into this rapid miner, and which is scalable. This particular tool is scalable and cloud ready. In a cloud also you can install it, and you can also focus on interpretable models like compliance and AI. For any regulated industries, you can use this uh, tool. So used across sectors. So this particular tool is used across sectors. Recently, we have also conducted a certification program, and there is a online AI prediction using rapid miner also we have conducted. If you go through Altair One website, you can understand about this like whatever the conference we have given here, means using rapid miner, and competition what we have conducted especially for the scientists and engineers. So most of the scientists has registered and they have attended this competition in altair1.com website as well, and we got good engineers appreciation by using this particular tool. And yes, if you see any data analytics and AI industries, so these are all the industries where right now they are moving to AI powered simulation and generative design technologies. They started utilization for this tool. And yes, data analytics and AI applications like industrial design, I can say Internet of Things, manufacturing companies can start utilizing this, and simulation industries. So whatever the names I have mentioned on the screen, so they have already started. Most of them are our customers in all the different vertical domains, are started rapid miner as well as the physics AI prediction. I can name it few of the customers like Kohler India in Pune has started, and Yushin India so has started using physics AI. Here in Hyderabad, we have Meda Servo, and we have CAD FEM, and Skyroot and Dhruva and Blue Jay Aerospace. These are also started utilizing physics AI for the whatever the AI prediction, which is reducing a lot of time for them, and they have appreciated this as well. And we have some of the emails and appreciations from the customer for the physics AI. And simulation applications using crash safety. As I said, our AI tools are domain neutral. Any kind of physics can be predicted with the help of AI ML. So here, AI powered simulation technology called Altair, especially you can experience and AI enhanced platform, which is suitable for all the engineers who are working on AI, ML, deep learning. Okay, so this particular tool will be helpful for them. Easy workflows, because it is a easy workflows, and it enables rapid evaluation of designs through advanced neural network techniques. Earlier we were supporting only graphical neural network, so right now it supports two different neural networks. So we are developing this particular tool in a very faster way by understanding the customer needs, and we are implementing and developing this particular tool in day by day, and we are releasing the updates as well. Earlier we were supporting only single material, now it is supporting multiple material. Earlier we were supporting a thickness for one part, so right now multiple thickness also it is supporting. So that is a development is happening with Altair. So we are taking the inputs from customer, and we are modifying our tool as per the customer requirement and delivering it in a time. So that is where the customer appreciations we are getting for that. And yes, using this Altair, okay. So we have a new AI augmented experiences, which guides the users through workflows, enables, and you can also generate your own AI models within this AI powered platform. And you can also extend the creation of reduced order models, AI models, which you can optimize the system simulations. Everything is solvable. Ask anything to the AI tool, and you can also solve everything with the help of AI enabled solutions with Altair. So Altair as a trailblazer, so using physics AI and RapidMiner and HPC resources, whatever we have, three different verticals, which empowers the users to utilize this particular technology in the system as well as the cloud. Also, you can utilize it. It's a cloud ready based simulation tools and AI tools. So one of our customer, MAPE, they have used for data visualization and machine learning, which helps them to predict failures in the field, understanding how their customers are using their products. So anything, whatever in the day-to-day life, whatever we are doing, switching on the lights or switching off the lights, switching on the fan. So these are about the data. So this kind of data, if you have it, okay, so that data you have to store in our RapidMiner tool, and you can predict it. Similarly, Maeve is doing that. So whatever the customer does, their customer does on their products, so they improve. They have implemented the same thing in using RapidMiner and digital twin technology using Altair, and they have finalized their product in a very faster way, and they have used AI capabilities of Altair, understand all the critical factors and which are contributing to their product maintenance. So this all they have implemented using AI tools, and they have validated it. So they have so that's where customer has appreciated Altair tool. And so this I'll skip it up because, and the other technique called shape AI. Okay, so Altair has a shape AI, which is nothing but it automatically recognizes the patterns and shapes in CAE module. Okay, so if you have a mesh data with you, okay, it recognizes the shapes and the patterns, whether it is panels or extrusions, or it may be a folded parts or casted parts. It will identify automatically on the existing mesh data, and it will group in a separate namings like casting, extrusion, panel, and precision. And it also gives the count to you. So by this shape AI, you can extract the features from specified geometry without additional input or intervention. So this using some algorithm, a shape AI algorithm, which uses the matching option. Okay, the solution will give you the shape recognition ultra fast. So by which you can modify very easily, and whenever you link the matched parts automatically when you do modification, remaining synced parts, it will be changed. So that is the advantage you have it here with Shape AI. So this is a display AI, which is a cloud. Yeah, it's a cloud neutral app which is available in Altair1.com. So you can use in the cloud itself. There will be a cloud license separately, and just you have to drag the explicit or implicit or CFD or thermal, any deck file, and you can change the inputs like lower and upper bound values. Okay, so here you are changing the values, depends on your requirement, lower and upper bounds. It may be a load value, it may be a material value, it may be a thickness. Okay, and execute the simulation here, and what outputs you are expecting or you needed, that you have to activate it and do the simulation. You can also check the solver window or output window, I can say. So it has done some 40 by 40 simulations here. You can see using the graphical plot, okay, as well as the machine learning trained model also you can check. It gives the ranking as well. Like if I change the thickness, what will happen to the part? If I change the, you can see this internal and kinetic energy, body forces, displacement results, how it is varying. So in real time also, you can just drag option is available. You can immediately change the thicknesses of that. And you can also right side, you can see the graphical plot for that. Similarly, you can also see graphical as well as the contour wise. So this is about the impact analysis. So just now we saw any a graphical representation. Now it is about hyperview results visualization. Once the result explorer has been called using a design of experiments using hyperstudy, we did it. So it has done the preview here. You can see this. So when I change the thickness of the inner tube, okay, this is the maximum thing. When I change the thickness to 2.05 for these two particular parts, so easily it is showing on the screen here. Means it is doing the prediction very faster here with the help of that. And yes, here, if you see here, integrated AI is a priority for companies today. So 10 times faster uh, increase. Okay. And if you see from 2021 to 2024, the increase of usage of AI has been most of the industries started utilizing, and they are getting good results, and time saving is happening to the industries here. Here we can see how AI is imperative from this particular document. I got it from 2019 Gartner study, where our customers, where the current customers shows the tenfold increase in AI projects over the next 3 years as well, uh, from 2024 to 2026. So that is the graphical representation how the AI utilization is going on in the market. So Altair is leader in AI ML, which is again in Gartner document itself. It has been published. If you see the leaders, challengers, and the niche players and visionaries, we have Altair in leaders as well. So it's all this magic quadrant for data science and machine learning platforms. So Gartner has submitted this report globally, and that's where Altair was named a leader in June 2024 itself. So Altair has been recognized for its comprehensive vision and ability to execute the real-time simulations using AI and ML and geometric deep learning techniques using digital twin as well. As you know, AI is now nowadays a part of everyday lives and can be found in a lot of consumer applications, I can say. So one of the important case study, like University of 20, they have done a blood flow. AI has some of the projects they have done. So within that is blood flow check. So real time augmented reality and visualization of blood profusion, they have used it. Then they used a deep learning to classify the areas of poor blood flow as well. So this device is much cheaper than the conventional devices, and it is suitable for in home use as well. So that is how this using AI research they have achieved it. And the again, if you see this German cancer research center, like they have used Heidelberg applied deep learning, which is another form of AI to medical imaging data to classify the tumor tissues versus normal tissue. They have done these AI and deep learning techniques. Similarly, Airbus, which is automatic defect detection via deployed running on embedded GPU. And another one is BMW, which is using a various sensors to predict whether the vehicle is oversteering. And Shell has developed models for earthquake detection so that the Shell company is doing that. And so this is how the different type of companies and working and projects are undergone, which was very interesting using AI and deep learning techniques over here. When I talk about AI, ML, and deep learning, so artificial intelligence is the origin for the field of machine learning. And when you talk about machine learning, is popular in 1980s itself, and now it is trying to overcome the limitations of uh, AI, applying statistical methods to the existing data sets, and it is reading the data from the existing things, and it is doing a geometric deep learning at the background. It is keeping and it is keeping ready the trained model for the new predictions. So that is where the deep learning is essentially used by machine learning techniques only, which uses a neural networks with a different type of neural network technologies. Uh, we have it in Altair. So that so one of the claims we can say, and essentially AI algorithms are designed to model all the dynamic systems. Okay. Here a just reminder about one of the major differentiations between ML and DL. So as I said, DL is subset of machine learning, which uses a neural network with usually a lot of hidden layers. So when we talk about ML, requires annotated or labeled data, correct? So deep learning is nothing but a neural networks, okay, which learns directly from the data. So in general, a lot of data is needed to improve the accuracy of the results prediction. So that is where we recommend all the users to give as much as data as an input so that it will give a better prediction to you as an output. And if you see this deep learning applications, for example, semantic segmentation, which is again a classical label. So every pixel in an image, so which is used to understand the scene at the pixel level, and that will be making. So I'll play this video so that it is useful for the like applications like autonomous driving, medical imaging, and I can say smart cities. So in this video, you can see the model differentiates like roads, cars, people, buildings. Each pixel get categorized in a real-time scenario. So what is the use cases over here when I do this kind of data reading using this video? So it self-driving cars detect lanes, sidewalks, and it also detects the vehicles. So medical imaging example, segment tumors or organs in scans. That is how this deep learning applications will help you. If you say vehicle detection, so it involves locating and classifying vehicles in images or video frames. If you give some video, okay, it will read the data from that video, and that can be helpful for the like use cases examples like traffic management and surveillance, smart parking systems, driver assistance systems. So for that, the key message to all the users, like whenever you want to use AI ML, these deep learning models are transforming industries by enabling machines to see, understanding, and make decisions in complex visual environment. Recently, Switch Mobility is our customer who has done same vehicle detection techniques with the help of our rapid miner as well as a digital twin technology in Altair. So Switch e-mobility, you can type in a Google. Switch Mobility has given a but like case study using their bus. They are into bus automotive manufacturers. So you can go through that particular case study. You can Google it also. So highway scenarios, if you say rain detection and removal also, you can do it with the help of AI. Okay, human aware navigation of robots, whether it's a human or a robot, so that also you can find it out. So these are the like key advantages whenever you have a requirement how to use in a better way the AI and ML. So these are all the options for us. If you say traditional machine learning versus a deep learning, which is again a you're going to perform end-to-end learning with the help of give it a raw data and the task to perform the classification, and it learns how to do this automatically. So the traditional methodology, machine learning techniques, you usually need a feature extraction, like step to learn discrimination information from data such as images. So whatever the images you have given it, it extracts the data, and then machine learning, it will understand this is a car. So that's how it does. So deep learning has become a dominant machine learning tool, okay, for a wide variety of domains. So one of the biggest success has been in computer vision, where it performs, okay. It uses a neural network like CNN. So it will prediction depends on that neural network technology, and it predicts. So Altair is also into digital twin, where you have a purpose to optimize the designs, operations, and maintain by linking the simulations plus real data. Yes, Altair has a digital twin technology where you can utilize, and how the digital technology in a market. If you see the graphical plots on the screen, which is highlighted for both operations and designs. Okay, here, the global digital twin market is projected to experience a significant growth within the various forecasts, estimating a compound annual growth rate. I can say CAGR. Uh, you can see that 38%, 40% year-on-year growth you can see. And digital twin technologies across industries such as manufacturing, I can say healthcare, automotive, aerospace, and urban planning. It will go on increase up to 2031. So this is a projected 2031 or 32. This is a projection graph. And yeah, this is about the bar chart and the increaseness in the 10 times increase in 7 years, the revenue wise for the company. And if you see the purpose of digital twin tools, in Altair, we have ROM AI, reduced order model technique called AI, physics AI, and Activate, Rapid Miner, Monarch, Panopticon, IoT Studio. So these are all the tools as a part of Altair you are going to get, where Altair is an open and flexible approach, and it's a cloud-based also available. User can also install in cloud, and you can also utilize the cloud-based solutions like, as I mentioned, ROM AI, Physics AI, and Activate, Rapid Miner, Monarch, Panopticon, IoT solutions. Using design and development, you can also simulate and test the products before physical production, and you can also optimize the design using real-time feedback and performance data. You can get it. Similarly, you can have a monitoring and real-time visualization. You can also continuously track the status and behavior of machines, systems, or environment. Okay, live data from the sensors you can predict it. So next is, you can see the predictive maintenance wise 24%. Okay. Like you can also forecast the equipment failures before they happen. So using this AI technology, what will happen is it is reading the data, right? So where exactly the failure is going to happen, it will show on the screen to you with a graphical plot or a contour plot. So that is where using this AI technologies, digital twin technologies, you can predict and you can take care of the predictive maintenance before failing the part. Okay, by which you can reduce the time, and you can reduce the customer feedbacks on the product as well. You can reduce the downtime and maintenance cost very easily. And performance optimization, if you see, uh, like improve, you can improve the efficiency, energy usage and output, where you can fine tune your operation based on real time world data. And you can also train and simulate it with the help of AI tools, where you can provide the uh, like you can get the safe and cost effective simulation using this physics AI and ROM AI tools of Altair. So this is about the digital twin purposes, like different uh, locations you can use it and you can monitor it. You can facilitate the design, and you can also scenario planning, working, predictive maintenance, production efficiency. You can understand with the help of this digital twin techniques of any product. You can find it out in a very easily. So here these AI based algorithms, this is a twin activate we call as in Altair. So where you can do the physics driven as well as the data driven. You can give the simple Excel sheet. You can also give the equation based simulation as an input. From 3D models, you can generate it. You can also create a block diagrams with the help of activate. You can also do the scripting. So these three things you can use it in activate, and you can do a physics driven simulation. If you have a data driven simulation, also you can do it. So there are many customers who are asked us, they have a water management system, they want to do it. If we talk about government, so government is releasing everyday water to the uh, villages, right, or the cities. So how the time management is happening, how much water is going out and storing at the back. So how much usage is happening for each and every house. How, so these are all the data. So that data also they have it. So most of the customers in recent IIT Guwahati also we have given some presentations. So most of the IITs also started working on AI based algorithms, data driven algorithms. So using that input, you can do the AI using Altair. So this is how Altair Activate, Altair ROM AI and Rapid Miner, Panopticon and Monarch will do the entire AI/ML prediction to you. So these are all the applications, whatever the names are displayed on the screen. So there is no code over here. It's a just data given, data will be predicted here. So that is how this Altair tools will work. IoT Studio, where you can also develop your own application and you can put it in a cloud. So where you can access in a Play Store as well, and you can utilize it. So IoT Studio also can use it. You can develop it. So this is a project where ROM AI is used as an operational digital twin to monitor and improve a sheet metal forming simulation. So using a digital twin for the operations using Hyperworks suite and engineering data, ROM AI and physics AI has been used. So these are all the tools for the operation. Okay, the objective is to understand when and why the process is like diverging from the nominal conditions. So by using the field data coming from the press machines. So that is where the input and the formed products like deformation measured through uh, physical tests. So that has been taken as an input. So various ROM AIs are trained using simulation data and then used during operation processing, like wherever the sensors are there, sensor data has been uh, collected and given as an input. So the calculated information is stored into the dashboard, which is designed. You can see this. What makes Altair best is So what are the 6 products in the CIE plus AI domain we have? So let's not forget about the rapid miner, which can be used in some CIE cases. So top products have their own UI. Bottom are embedded to other products such as Hypermesh and Activate also. So I can explain where Design AI and Hyperstudy in the cloud, okay, and Design Explorer in Hyperstudy in Hyperworks. So there are interchanged, uh, like Design AI is a cloud-based. Hyperstudy is also you can use cloud-based. Design Explorer, which is there in Hypermesh window as well as cloud-based also. And they're also based on these tools. You can explore it. You can do the uh, like you can get the best expertise to develop the technologies and to acquire the technologies with the help of Altair. And we have a easy to use, flexible workflows. Okay. And Design AI has seamless job submissions we have in the cloud, which is using Hyperstudy. Design AI also has access to the data directly. Using Hyperstudy, you can call the data and you can generate the synthetic data, and that synthetic data can be used for the design exploration. What if scenarios? If I change the material, what will happen? If I change the thickness, what will happen? If I change the shape, what will happen? So in Design Explorer study, you can get it. So that video already have shown and displayed on the screen. Yes. And coming to the rapid reduced order model, you can see this ROM AI, which is a no code application for AI powered system tools. So reduced order model technique. So whatever the real time JCB working, lifting the material and dumping into the truck. So that kind of scenarios. High fidelity models. Generally, if you go to the high fidelity models, it will take longer duration of time to the simulation, right? So that's where we take the data from the simulation and test data as well. So that will be converted as Excel sheet and that will be imported into ROM AI director. So which you can see on the screen, and you'll get the data of X, Y, Z, angle, force, torque, everything as an input to you. Okay, from the real-time data, you're converting this and you're training that model. You're doing the neurons here 300 by 300 and you're training that for 2500 epochs. So it is training that model, machine learning, you're doing it. So it gets into the deep geometric deep learning and it understands the loss functions of whatever the input you have provided. Okay. So this is a activate window. Within that activate window, you can see this ROM AI, where you are going to use the reduced order model technique, connecting to the high fidelity model. So what happened is the runtime is very faster when you compare the high fidelity as well as with ROM. It will take less time. So 1,000 times faster, I can say. So that is where the advantage of ROM AI, you can see it is very easy to use. 1D integration system models using Activate, you can do it. Okay, I'll just quickly I'll go through. These are the steps for ROM AI because we are out of time. And yeah, many case studies are also there. So quickly we'll get into the case studies. As I said, no code applications, data, system dynamic model, static and dynamic models using Altair technologies, you can simulate it. Okay, so reduced order models techniques. This is one of the example, which is again system identification of battery cells. You have a test data using ROM AI, you're predicting. So good accuracy compared to the real time as well as the like ROM AI prediction. You can see at the right side. Okay. It's about the battery simulations. So this is the entire process of ROM AI workflow. Okay. And these are the self-paced training programs are available online in altair1.com. You can go through the workflows of sensors, telemetry, multi-body dynamics, structure related, data driven. So we have a many case studies related to ROM AI and physics AI. 100 plus case studies are available in our website. So the accuracy wise, we are excellent, no doubt in that. So we are getting more good results, more appreciations from the customers, less time it is taking for doing all the real-time predictions. So this is an example of leaf springs. There are many examples. Speed up a system level simulation for the analysis of full vehicle dynamics. Solution is reduced order model. Okay, kinematics based, and good accuracy of the solution is achieved with the help of reduced order model technique. Solenoid valve. This is again another case study using AI tools of Altair, ROM AI and co-simulation activate. And yeah, so these are the predictions. So excellent accuracy greater than 98% compared with high fidelity simulation that is nothing but a traditional CI simulation. They have compared it. Crash, you can take any physics, the prediction wise, ROM AI, activate, and physics AI are more good at the accuracy level. CNH is one customer who is into agricultural industry. So using ROM AI, so there are many case studies. You can go through our website. I'll just quickly, I'm doing this cooling circuit. You can talk about sensor bracket, multiple iterations. So that is where the advantage you have, easy to use, no code application, open and flexible. Okay. And yeah, speed, accuracy, automation, openness to the tool. It fits into existing workflows without any disruption. And just I want to summarize the benefit. Altair combines simulation plus AI ML tools plus cloud to empower the digital transformation. So customer will have a benefit for the faster innovations like low cost, and you get the better products in a very less time. And it is an open and flexible tool. It's a compatible with various simulation platforms and supports different file formats. So that is where Altair's tools are like data science plus rocket science will be benefited all our customers, and different variety of industries can utilize Altair tools using AI ML technologies. So thank you. I have taken a 10 minutes higher than the actual presentation time, and sorry for that. And I hope you have understood the AI ML technologies of Altair, and open for questions. If you have any questions, I will note down.
Yes, thank you, Guda, for the wonderful presentation you have taken us through. So we have few questions. We have a question from Mr. Shamdev. I will just read out the question. So he's saying that I'm working with CAE simulation results for a component that has several different design versions. If design and loading condition, loading magnitude, or whether it is concentrated or surface load is changed, keeping boundary conditions same, would physics AI be able to predict the results for new design?
Yes, sir, whenever we talk about the new design changes, okay, and load changes, actually we need to train, sir. Whatever the changes you are doing, right, you have to train and keep it ready. And then obviously
Okay,
the physics AI will predict whenever you get a new design, okay? So within this trained model, whatever the changes you are saying, right, that should be there, sir. One or two models. That would be better. It will give you the prediction in a very good way.
okay. Adding to his question again, he has asked in CAE for the same component, the area where the load is applied can change. If a new loading area is introduced, can physics AI still predict the new designs, keeping the boundary conditions same?
Okay, only load value is changing.
Yes.
Yes, yes, it will predict, sir. If you give me
Okay.
time,
Mr.
so just yeah, you
Yeah.
can go on
In
the questions.
the meanwhile, Mr. Shamdev, you can just unmute yourself and you can ask if you have any further queries. We have unmuted all the attendees. If you have any queries, you can just unmute yourself and you can ask your queries now.
I hope you can all see my screen, right?
Yes.
So actually, customer has given us seven S3D files to us, like six design results, I can say. Customer has given six designs are different designs. Okay. It's a door handle. It's a door handle. Okay. And using this physics AI prediction with a trust and trained model, if you see prediction wise, contour wise, displacement, because this is what not matching because of we have a less S3D files. The design, whatever they have provided, it is very new, which is not there in the trained model. But still, this is a new design which was not there in the earlier trained model. The prediction compared to the real-time CA simulation and physics AI prediction, almost 74% it was matching it. So this is what observations, what we observed and we have explained to the customer, like with the 6 available S3D files, the model achieved prediction of 74%. The training carried out for up to 5,000 epochs, and during experimentation, it was observed that adjusting width and depth parameters can significantly impact the prediction performance. So whatever the width and depth as changes are happening, so that you have to give a proper input in the physics AI. So that automatically it reads the data and gives the proper prediction to you. So this is a current like one of our customer case studies, sir.
Hey, hi. Hi, Guda.
Yeah, hi, sir.
Hi. I just had some questions to be asked regarding physics AI.
Sure,
As
sir.
mentioned in the question, yeah, as mentioned in the question, like, would we be like, if I am changing this, if there are many design versions coming up in upcoming, so if I'm changing the loading conditions or the load magnitude or the concentrated loads, if it is changing, would the new design be able to, would physics AI be able to predict the new designs?
Yes, sir, it does. It will
Okay,
do.
it
Physics
does,
AI
right?
will
Okay.
predict the results. Yes.
So, and also if the loading area is changing, so still it would be, if it is the same component, and if the loading
Yes.
area is changing, it would be, say, would also be able to predict it, right?
Yes. So if you see my video, automotive hood example, actually the fixing
Yes,
condition
yes.
is same. The loading was at the front side, head impact. Suddenly I have moved that using a move option. I have translated to some other location. Okay.
Oh, yeah, yeah.
Location has
Yes,
been
yes.
changed. Now in current version 2025.1, you can also change the magnitude and you can also do the prediction.
Okay, 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 sure, got it. And one more small doubt I have is regarding the prediction with fatigue and strength analysis simulations. So it doesn't for the physics IA, it doesn't matter whether it is a strength analysis or fatigue analysis, right? It needs only the results as a trained model. So to the trained
Exactly.
model, we
Correct.
just have to. Okay, so it doesn't depend upon whether it is fatigue or strength analysis.
Correct, sir. Correct.
Okay, okay. Thank you for your, thank
Thank
you
you,
for
sir.
confirming that. Thank you.
Okay.
Thank you.
Thank you, Mr. Ranjit. Mr. Shamdev, do you have any further queries? You have unmuted yourself. Also, I request all the other attendees, if you have any questions, you can raise your hand or you can just unmute yourself and ask your question.
What do you
Hello, Karthik.
Yes, sir.
Yeah, actually, for the previous files, we have some different formats, not in the H3D. So,
Okay.
in that terms of like animations, can we train using up animations?
What
Zip formatted
solver
file.
result files, sir? What solver result files are those?
It is also in the LS9.
LSDNA. So I can
Yeah,
say that dot key is the input file, right? Sorry.
yeah, input file.
Uh,
I'm asking the results files because for
Result file extension will be,
long, yeah, long
yeah,
back
that you can
files we are
import, sir.
not
No
able to
worries.
maintain,
You
right?
can call. You can call in Hypermesh. No worries. In
Okay,
physics AI, you can call the data sets of S3D. Okay. And you
okay.
can train the model. And whenever the new design comes, immediately you can predict it.
Okay, thank you.
Yeah, thank you, Mr. Munuswamy. So we have next question from, I guess, Mr. Manoj Kumar Meena. So can you just unmute yourself? Mr. Manoj Kumar, can you just unmute yourself and ask your query? Or else you can type in the questions tab. Okay, I guess there is some technical issue at his end. In the meanwhile, I request other attendees, if you have any queries, you can ask it here. Also, I would like to inform everyone that we'll be sharing this webinar recording along with the presentation with all of you. So tomorrow, if you have any queries, you can always revert me on my email, and we will try to answer them.
I hope you everyone can see my screen. Okay, so you can see this crash
Yes.
box design exploration in seconds. So there are many case studies done by our users, and they have published in our website as well. We have published it. It may be automotive, aerospace, heavy engineering. You can go through this case studies.
Okay, thanks, Kuda, for showing this case studies. There are no other questions, I guess. Yes, there are no other questions in the chat window as well. So I just want to thank you for this wonderful presentation, and I would like to thank all the attendees for taking out the time and attending our webinar. So thank you, Guda, once again. Thank you, everyone.
Yes. Thank you so much. Thanks, one and all, sir. Have a good day. Thank you.
Thank you. Thank you. Bye.
Thank you.